In this lecture, we are going to talk about similar triangles. We take triangle ABC, and on one of its sides, say AC, we pick a random point D. We take the line through AB, and through D, we construct the parallel line to AB. We name the intersection between side BC of the triangle and the parallel line through D to be the point E. Effectively, we have triangle CDE. For this lecture, we are going to show the triangle ABC is similar to triangle CDE. That is, the length of CD divided by the length of AC is equal to the length of CE divided by the length of BC, and in turn, this is equal to the length of DE divided by the length of AB. In short, ratios between corresponding parts between the two triangles are preserved. In order to be able to show that all these fractions are equal, the first thing that we are going to do is to find the area of triangle CDE. We will find this area in two ways. The area of a triangle is half the base times the height. For the first formulation of the area of the triangle, we pick CD as the base of the triangle, with the point E as the opposite vertex. From the vertex E, we construct the altitude to segment CD. We call the intersection point between this altitude and segment CD the point G. Therefore, the area of the triangle is half CD times EG. For the second formulation, we choose the segment CE as the base of the triangle. This time D is the opposite vertex. From D, we construct the perpendicular to CE and get the corresponding altitude. Suppose the intersection point between this altitude and segment CE is the point F. Then the area of the triangle is equal to half CE times DF. Next, we determine the areas of two other triangles. The first triangle is triangle AEC, and the second triangle is triangle BDC. First, we subdivide triangle AEC into triangle AED and triangle CDE. On the other hand, triangle BCD is made up of triangle BED and triangle CDE. Hence, triangle AEC and triangle BDC share triangle CDE. We already have formulations for the area of triangle CDE. We proceed by finding the area of triangle AED, which is part of triangle AEC. Then we find the area of triangle BED, which is part of triangle BDC. We observe that the two triangles share the common side DE. Using DE as the base of triangle AED, the corresponding altitude will be the distance of the point A to the line containing DE. This distance is simply the distance between the line DE and the parallel line through A, which is line AB. For triangle BED with DE as the base of the triangle, B will be the opposite vertex. The distance of the point B to the line DE is the distance between line DE and the parallel line through B. Again, this is line AB. And so we have the same altitudes for the two triangles. And so the area of triangle AED is equal to the area of triangle BED. And both of these are equal to half the base, which is DE, times the altitude, which is h. As a result, because we have these two quantities as being equal, and of course the area of triangle CDE is equal to itself, the area of triangle AEC and the area of triangle BDC are equal. Now that we have shown the equality between the areas of triangle AEC and triangle BDC, we will have to find different formulations for their areas. For triangle AEC, we use segment AC as the base, and so E is the opposite vertex. We already have constructed the altitude from the point E to segment AC. This altitude terminates at the point G on segment AC. And so the area of triangle AEC is half the base, which is AC, times the altitude, which is EG. We do something similar to triangle BDC. This time, we use segment BC as the base. And so point D is the opposite vertex. Again, we had already constructed the altitude from point D to segment BC. This altitude happens to be the segment DF. And so the area of triangle BDC is equal to half the base, which is BC, times the altitude, which is DF. Now we divide equals by equals. For the first fraction, we divide this area of triangle CDE by the area of triangle AEC. And so 1/2 and EG cancel out, leaving us CD divided by AC. For the second division, we take this other area of triangle CDE and divide it by the area of triangle BDC. We must remember that the area of triangle BDC has the same value as the area of triangle AEC. And so 1/2 and DF cancel out, giving us the fraction CE divided by BC. And so we have the first equation in this set of equations. We just need to show that these two fractions are equal to DE divided by AB. To proceed, we take triangle ABC and triangle CDE again. On segment AC, we construct the point C prime so that the length of segment AC prime is the same as the length of segment CD. Then we take line BC, and through the point C prime, we construct the line that is parallel to line BC. We name the intersection between this parallel line through C and segment AB as B prime. So we are now in exactly the same situation as we had before when we showed that these two fractions were equal. We were using C as the apex vertex. This time we are using A as the apex vertex, and we are using lines BC and B prime C prime as the parallel lines. And so we have AC prime divided by AC equals AB prime divided by AB, which is exactly the same relationship that we found for CD, AC, CE, and BC. To bridge the gap so that we include DE divided by AB in the set of equations, we use the idea of congruence between triangles. The triangles we are referring to are triangle AB prime C prime and triangle CDE. Between the two triangles, angle A and angle CDE are congruent because these are corresponding angles formed by parallel lines with line AC as the transversal. Then we have that angle AC prime B prime is congruent to angle ACB. These are corresponding angles formed by parallel lines with AC as the transversal again. And finally, we had constructed C' so that the length of segment AC' is the same as the length of segment CD. And so by angle side angle, triangle AC' B' is congruent to triangle CDE. Because corresponding parts of congruent triangles are congruent, or by CP/CTC, the length of DE is equal to the length of AB'. And so in this fraction, we replace AC' by its equal CD, and in this fraction, we replace AB' by its equal DE. And so we have DE divided by AB equals the two other fractions. And this completes the exercise.